Hi everyone, today we are going to be looking at cross multiplication and then we're going to look at some different things if they're proportional or not, and that's the second part of this. So to cross multiply, you've done it in 6th grade, you did it in 7th grade. We're going to just retouch and do it again today. So when you go to cross multiply, all right, it sounds exactly what it is. So I'm going to go ahead and circle the ones that are across from each other. All right, and that's these two guys, 2 times 5. So when you cross, you are going to multiply. If you wanted to, you could put an X right there where the equal sign is. But I'm going to say, what is 2 times 5 in the calculator? And you should get 10. And then the divide part, I'm going to divide it by 6. So in the calculator, I'm going to put 10 divided by 6. And it should give me 1.66666. Okay, repeating. So I can put it as 1.6 repeating. I could put it as 1 2/3 as a fraction. Those are my two options for answer choices. All right, so I multiply across the 2 times the 5, and then I'm going to divide by what's left, that's 6. So let's look at number 2. Kind of goes the opposite direction. So 15 times 19 is what I'm going to multiply. So I'm going to do that in my calculator real quick. And I get 285. Now, if you're using a yellow calculator, it's going to be easier, or you can use Desmos. You can pull open that. I'm just using my phone calculator really quick to get it done. And then you're going to divide by 20 because that's the number that is left over, and I can put it in a small circle for you. So what is 285 divided by 20? Your calculator should give you 14.25. Again, you could put it as a fraction if you wanted to, but I'm going to leave that as a decimal. The next one, 7 times 52. All right, again, go to your calculator. It should give you 364. And then I'm going to divide it by what's left, which is the 21. So in your calculator, type that in. And again, you get 17.33. Some of these will work out really nicely, and some of these will be decimals. You can change them to a fraction. 17 1/3 would be this fraction. Okay. But that is what P would equal on this one. So try numbers 4, 5, and 6. Think to yourself, which two are directly across from each other? Okay, so that one would be 16 and 32. And now multiply, and now divide by the 24. So try 4, 5, and 6. You can pause it. We'll go back over them in just a second. All right, so you should have got 16 times 32 and got 512. And 512 divided by 24 should have given you 21.33. Again, you can make that into a fraction. If you did, that's just fine. Number 5, you should have done 3 times 73. And got 219. And then divided by 27, which should give you 8.1 repeating. Let me make that line a little bigger. Alrighty. The last one, you should have did 6 times 42. Okay, and got 252. And then divide by 87. I do have to say, on your Schoology, there will be some that work out completely nice, no decimals, and there will be some that will have the decimals. So this one's a little weird. The decimals definitely longer. You could see what your calculator would simplify it down to as a fraction, but it's going to be, I'm going to go ahead and just write 2 decimal places, 2.89. Okay, so that's a quick review on cross multiplication. The next thing we're going to look at is if something is proportional or not, and what that means. So I went over to my next sheet of paper. All right, so what is proportional? Proportional means that the y-intercept is 0. So we looked at y-intercept earlier in the week. But when your y-intercept is 0, your graph or your table, your data that they give you is called a proportional. So the clues that you want to look for, that the graph goes through that origin. The y-intercept is 0 when you do this. So I'm going to write out here the keyword origin. And it's going to be not a nice writing because it's hard to write. Alrighty, so origin. And then y divided by x is the same for each coordinate. And so this will be when you're given a table, and we'll look at that in just a second. So look at our graph. This blue one here shows that it is proportional. Notice how it goes right here through the origin. If it kept going, it would go through that origin. All right. And then this is a good key thing to remember. Your equation will look like this. For example, y equals 2x. Okay. That is a great example for that. Or y equals 1/4 x. Or you could make it a negative 1/4. So those would be what an equation would look like for proportional. Now, the non-proportional, let me use a different color, it is going to go through some other y-intercept. Notice how it doesn't go through the origin anymore. It actually has a y-intercept of 3 on this example. Okay, it's going to be any other number that is not 0. For example, this one, the y-intercept was 3. So we know it has to be non-proportional. The same for this equation. You're actually going to have a number at the end of your equation on this one. You did not have that over here on the other one. So for example, you could have y equals 2x plus 3. Okay. And you can compare it to the other one. All right. So if you notice, your line goes through the y-intercept, not at your 0. All right, so we're going to look at an example of a table next. So up here on the clues, part B, you said y divided by x is the same for each coordinate. So if we looked at this table, you can take this coordinate here, 2, 6, and that's what they did. They put 2/6. And is it the exact same as 6/18? Yes. You could put this in your calculator. You could put this in your calculator. They should give you the same decimal, okay? Or in 6th grade, they taught you to butterfly. And if this number, when you multiply 6 times 6, is the same exact as 2 times 18, then yes, they are equivalent. They equal each other. It is proportional. Okay, 2 different ways you can do that. For non-proportional, when you go to put this in the calculator, right, it gives you 1/5 or 0.2. And they took this one, by the way, if you didn't see where they grabbed it from, that coordinate. And then 6/22, they grabbed this coordinate. You can grab any coordinates. It's really good to do the entire table to make sure they don't mess with you and throw in something else. But if you take 6 divided by 22 in your calculator, you should get a decimal that looks like 0.27 repeating. And those two are not the same decimal, okay? If you were to multiply 6 times 10 and you get 60, 2 times 22 would have given you 44. So even if we did butterfly method, it doesn't work either, okay? So try those. Might be because you have a calculator. The easiest is just to simply divide, put 2 divided by 10 in your calculator to show that. So let's look at, there's a graph, see down here. These graphs might look familiar. They're the ones we used for linear and is it a function? So we're not going to answer all of these questions. We're really going to look at these graphs to say, are they proportional or are they not? So let me get my pen out. Take a look at this graph. It's a little bit tiny, but we can see that the origin is located right here. That's 0, 0. Does your line go through this point right here, 0, 0? No, it doesn't. So it is non-proportional. I'm going to write non. Okay. Look at this one to the right side of it, where we have the moon weight and the earth weight. Okay, does it go through 0, 0, which I'll mark it right here. You should learn where 0, 0 is. Yes, it does go through that. So it is proportional. So let's go to the next couple of examples. We are looking at this table. So when x is 0, y must be 0 for it to be proportional. And this one shows that. So the other option you would have had, it would have said x is 0, and it maybe would have given you a number where the y was, and it would be non. Okay, we looked at that example up at the top there. And then we're not doing this one at all. Let's see if there was another one below it. I don't believe so. Okay, so those are some examples of proportional and non-proportional. Get you back up here to the notes. If you have questions, let me or Mr. Joel know.